Hello there, Johnson once again, and this time round I'm introducing Retina AI as our final presentation. So, moving on, our problem has always been severe shortage of specialists, whereby we have short specialists to attend to very many people, whereby one ophthalmologist attends to 1 million people, which is very straining. And 85% of the population lives in rural areas. So most of these people who are old, elders, and the people with so many different eye problems can be in rural areas. So we target them. 80% of these cases are detected at advanced and visually threatening stages, which is not good. So rather, someone would rather check their eyes and find out an issue earlier so they can resolve it without waiting for the lasting minute. Yeah, so we are targeting rural areas because most of these people in rural areas may not have enough access to ophthalmologists. So instead of transporting people from rural areas to come up to the towns, they will just be able to be helped immediately. Why does it matter? Is manual diagnosis or accuracy only 70 to 80%. Each diagnosis takes 15 to 20 minutes, slow in care, and without early detection, blindness can become irreversible. So its air solutions struggle due to class imbalance, label explosion, and explainability needs and mobile deployment constraints. Yeah, so in many Ugandan districts, a patient may travel over 50 kilometers just for a single screening, which is not good, and it can be too late to prevent this vision loss. So our solution is a multi-architecture ensemble system for mobile retinal screening, whereby our AI solution multi-architecture ensemble. This one involves the generation 4 framework combining LVMs with clinical knowledge graphs. Then, of course, we have graph-based reasoning to treat our image passages as nodes, analyzing relationships between the zonic to mimic human medical diagnosis. So, our key features, we have mobile optimized, where we achieve 87% size reduction and speeds that have improved, and also clinical trust. Then, of course, we have high accuracy. The graph clip model achieves at least a 91% accuracy, solving a label space explosion problem. So why is it different from and better? Because it leapfrogs from single disease detection or generation 1, screening at least 45 distinct pathologies simultaneously. So in intelligence, it replaces that black box classification with relational reasoning, identifying spatial connections between the optic disc vessels and lesions. So it uses noise distillation and int8 quantization to run complex LVMs on standard mobile hardware. So our technology and architecture is simple. It simply involves data input, whereby you input the retinal images, then you pre-process them. This is where the image sizing, normalization, and data augmentation happens. Then we have the input serving. Then it moves it to the model layer, where there's feature extraction using the VT visual transformer. Then the graph construction, we are patching nodes and adaptive edge weights considered. Then graph message passing, whereby we have the sparse talk attention levers. Then disease prototypes and also the classifier, which combines the global disease aware context. Then this moves it to the API inference layer. This is where our model was hosted on Hugging Face, with an inference server built with Gradio for our front end, and also our UI, which is also on Hugging Face using Gradio. And of course, the extensions which send diagnostic feedback to clinicians and integration with EMR systems or hospital databases. So our business model, how we make money here is through SaaS subscriptions, like SaaS, software as a service, where people can subscribe for at least a month, probably $10, depending on the strength of the model, and also licensing fees. Then pay per use APIs. You can sell our APIs for use. Then we also have value-added streams like direct one-time sales to governments in developing countries. Yeah, like you can be able to collaborate with other countries, with their governments that maybe have been affected. Direct revenue models, we have data as a service, consulting services, and ecosystem partnerships. Yeah. So our vision for growth is scaling from lab to edge, deploying our 17 mobile optimized model to rural village. Then, of course, we have clinical mentorship. These are like the future prospects. Then, of course, we look at the incubation and data partnerships, collaboration with health institutions to integrate with EMR systems. Then, of course, funding for hardware testing, resources to test the system across equipment variations. Yeah, so that is how we look into the future for it. And also, the vision is just simply from lab to edge. We want to move from the lab, just going to labs to always make checks, eye checks. No, people can actually make checks from their homes. Then the full ecosystem integration, whereby we are just scaling from standalone screening to a fully integrated system that sends real-time diagnosis feedback to clinicians and updates hospital databases automatically. So this closing statement is this retina AI is a non-invasive window to system health. So with eye detection capable of preventing 95% of loss, we can be able to ensure that the geographical cost is no longer dictated by patient side. So this is our prototype. It simply has the LVM screen whereby you can add the image of the retina, or you can actually use the camera, as here you can see, which can scan. It can be integrated to the system. Then of course it predicts the disease. Then you choose the disease. You can paste from the clipboard, like here we selected the disease, you put it there. Then after selecting, you tap submit, then to predict here and show you the percentage. Thank you very much for listening. Have a good day.